Welcome to comp452 Computer Architecture. Today we will begin our study and discussion of pipelining. And pipelining is almost universally used today. So pipelining, what is pipelining? Pipelining is actually an implementation technique in which multiple instructions are overlapped in execution, and we will see in detail what this means and what are the implications of this concept of pipelining. And we begin with an example of laundry to describe and discuss the concept of pipelining. So let's suppose that we want to wash clothes. Oh, I think I promised you guys that the lectures will be in Urdu, but you didn't give me any feedback, so let's continue the lecture in English for now. All right. So suppose we want to do the laundry. We want to wash our clothes. So what are the steps? What are the usual steps involved in doing laundry? So we are assuming that we are using machines to do the laundry. We are not doing it the old way it was done in the subcontinent. So, or maybe I should say, we will not be doing it the way dhobis used to do it a few decades ago. So we will be using machineries. So we will be mechanized dhobis. So the first step is usually that we put one load of clothes in our washer, and we put the detergent in it, and then we turn on the water, and when the water fills the drum, it starts agitating, and basically the washing cycle or wash cycle starts. So when the wash cycle is finished, we take the clothes and we actually put them into dryer. We put them into dryer and then we start the dryer. So this is, we can say this is the second step. And once the dryer has dried the clothes, we put the clothes on table, and we press them or we fold them, and then we in the last step we put them away in the wardrobe, right? So in the third step, what we do is we press plus fold the clothes, and in the fourth and final step we hang them in the wardrobe. I hope the spellings are correct. If this spelling is not correct, please do let me know. Okay, so these are the 4 steps. Now let's assume that each of these steps takes about uh, about 30 minutes. 30 minutes. This also takes 30 minutes. 30 minutes. And this one also 30 minutes. So it means completely washing, drying, pressing and hanging one load will take 2 hours. 2 hours. Okay. So that each of these takes 1/2 hour. 1/2 hour. And this is also 1/2 hour, and this is also 1/2 hour. So after we have completed one load, we start the next load, and then after that we start the next load. Okay, so what we do is, let's suppose we have n loads. So it will take us 2n hours to wash them, to hang them in wardrobe. Hang them in the wardrobe. Okay. Wardrobe. Now let's suppose that let's graphically represent this. So we have half an hour for washing, half an hour for drying, not drawing, another half an hour for pressing, and then another half an hour for hanging in the wardrobe. So let's suppose that this is 6 p.m. So by the time we finish, this will be 8 p.m. So then at 8 p.m. we start our next load. We wash it, we dry it, we press it, we hang it. So this will be about 10 p.m. Alright. And let's do one more. Wash, dry, hang. Wash, dry, press, and then hang. So this will be 12 a.m. midnight. Now let's suppose that we have 4 guys at our disposal. So which 4 guys are going to help me in doing this laundry? Okay, let's say that Irfan Iqbal is standing on washer. Sir Omar Habib Khan is standing on dryer, and let's say my TA Muhammad Usman is standing on press, is doing the job of pressing the clothes. What the hell? Okay, and then who should be the 4th guy? Who would be the 4th guy? Let's assume that Hasnat Ahmad Java is hanging the clothes. So this is Irfan, this is Umar, this is Usman, and this is Hasnat. This is Hasnata Majava. So let's do another strategy. At 6 p.m. I put first load in the washer. Okay. At 6:30 p.m. that washed load is handed over to let's say Umar to put into the dryer. And what Irfan Iqbal does is he gets a new load and puts it in the washer. So at 6, this was 6 o'clock, this was 6:30, this was 7 o'clock, and at 7 o'clock Usman takes the dried clothes and starts pressing them. Okay. And Umar takes the load which has just been washed and puts it in the dryer. And Irfan takes third load and puts it in the washer. So at 7 p.m. washer, dryer and pressing, all three operations are taking place in parallel. At 7:30 Hasnata Majava starts hanging the clothes in the wardrobe. At 7:30, this is 7:30, and Usman, he takes the second load and puts it on the table for pressing. Umar takes the third load and puts it in the dryer, and Mr. Irfan Iqbal gets the fourth load and puts it in the washer. Now let's assume there are only 4 loads. So once this load has been hanged, this first load has been hanged, Hasnata Majava will become free, but Muhammad Usman, Hasnat will not become free. Hasnat will get the second load and put it in the wardrobe. Okay. Usman will take the third load and put it on the table for pressing. Sir Umar will take the fourth load and put it in the dryer. But now, since there are only 4 loads, Irfan Iqbal doesn't have anything to do now. So he just waits there, sips his cup of coffee. Okay, at 8 o'clock, this is 8 o'clock, this was 7:30, this was 8 o'clock. What happens at 8 o'clock? At 8 o'clock, now look, first load has been completely processed by 8 o'clock. First load, let's write here, first load complete. First load hanged in wardrobe. Okay. Now what happens at 8:30? What happens at 8:30? At 8:30, the second load has been hanged. Second load hanged in, let's call it wardrobe, WR. Okay, at 8:30. Now at 8:30 what's going to happen? Hasnatama Java will get the third load and start hanging it in the wardrobe. And Usman will get the fourth load and put it on the table to press. Alright? Clear? So now you can see that at 9 o'clock, this is 9 o'clock, this is 9 o'clock, 9 p.m. 9 p.m. This was 8:30 p.m. 8:30 p.m. Okay, at 9 p.m. third load hanged in wardrobe, and then at 9:30 p.m. Hasnatam Java at 9:30 p.m. or at 9 o'clock. At 9 o'clock, Hasnatam Java takes the final load and starts hanging it in the cupboard or wardrobe at 9 o'clock. This is the time. At 9 o'clock he starts hanging the last load, and at 9:30, this is 9:30, the last load is also hanged. Last load hanged in wardrobe. Okay. Now see, if you were doing it in the old style, washing 4 loads would have taken you up to 2 a.m. or 8 hours. So this style, this is called a single cycle style. Single cycle operation. You first complete one set of load and then start with the second one. And this is pipelined approach. This is pipelined approach. Pipelined approach. And in this pipelined approach, these W, D, P and H, these are called pipeline stages. So in this case, what is the total time taken to wash 4 loads of clothes? We started at 6 p.m. but we completed at 9:30, which means 30 minutes, 3.5 hours. So 3.5 hours to wash 4 loads, and in single cycle it took us 8 hours to completely wash and hang 4 loads. Okay. So what you see here is that washing 1 load still takes 2 hours. Look, third load takes 2 hours. This is 2 hours. Fourth load takes 2 hours. Second load takes 2 hours. It starts at 6:30, ends at 8:30. First load takes 2 hours. Starts at 6 o'clock, 6 p.m. ends at 8 p.m. So washing 1 load still takes the same amount of time, same duration of time. Okay, but washing 4 loads now take 3.5 hours. In single cycle operation it took 8 hours. So what is the approximate improvement in this case? 8 over 3.5 What is 8 over 3.5? Let me pull up my calculator. Where is my calculator? Should be somewhere here. I have to look for it. Wow, I do not have calculator here. This is a very old. Okay, let's do this. Let's use this calculator. 8 divided by 3.5 equals to 2.285. It's 2.285. So let's call 2.285. 2.285. So it's approximately equal to 2.3. So we have an improvement of an improvement by a factor of 2.3. So now it's taking 2.3 times less as much as it took in single cycle operation. Okay, now let's try to generalize it. Let's assume that we have very large number of loads. We have n loads. So if we have n loads, single cycle operation will take 2n hours. Okay, now let's see here. We want to write an equation for a pipelined approach. So look, first load took 2 hours to wash. First and second both combined took 2.5 hours. First and second and third took 3 hours. First, second, third and fourth took 3.5 hours. So when we had just one load, it took 2 hours. When we had two loads, it took 2 plus 1/2 hour. When we had 3 loads, it took 2 plus 1/2 plus 1/2 hours. When we had 4 loads, it took 2 plus 1/2 plus 1/2 plus 1/2 hours. Okay, now you tell me what will be the equation for n loads. For n loads, it will be 2 plus, look, when n is 2, you have 1/2 here. When n is 3, you have 2 1/2s here. When n is 4, you have 3 1/2s. So it means it's 1/2 of n minus 1. So 2 plus 0.5 into n minus 1. This is the time taken, Tn, time taken to wash n loads with pipelined approach. Okay, and this is Tn is equal to 2n for single cycle. It is hours, HOURS. Okay, so now let's see what's the speed up that we get. Let's do it on next page. This is our next page. Let's make it so speed improvement. You shouldn't call it speed improvement. Oh, sorry, it's improvement. Or we should call it performance improvement. Performance perfor sorry, what the hell is happening here? Performance gain. What's the performance gain? It is equal to 2n divided by 2 plus 0.5 into n minus 1. That's the gain that we get. Now let's see what happens when n becomes very large. What is the gain when n approaches infinity or n becomes very large? It is, when n is very large, we can replace n minus 1 by n. So this becomes 2n over 2 plus 0.5n. Now when n is very large, 0.5n will be much bigger than 2, so we can ignore 2. So this becomes 2n over 0.5 and this n cancels and we get 4. Alright, so what this means is that if we have very large number of loads to wash, then washing them with a single cycle approach will be 4 times slower compared to washing them with pipelined approach. Okay, so it will be 4 times faster to wash it using the pipelined approach. And how did we get this number 4? You can see that here we had 4 stages of our pipeline. First stage, second stage, third stage, fourth stage. 4 stages of our pipeline. Alright. Okay. So this is the advantage of using the pipeline approach. Now it is very important to note that pipeline does not improve the execution of does not improve or does not reduce the time to wash a single load. No, it doesn't. We saw that whether it's a pipelined approach or it's non-pipelined approach, washing one load will always take 2 hours. But what we are doing here is that we are overlapping the operations, we are keeping the pipeline busy all the time, and because of that, after the first load is complete at 8 p.m., every half hour one more load is completed. Every half hour one more load is completed and it is hanged in the wardrobe. So this is the advantage of pipelined approach. Now if somebody says that pipeline reduces the time of execution of a single instruction in a microprocessor, he is not right. It does not improve the execution time of a single instruction, but it improves the instruction throughput. Instruction throughput is the number of instructions being completed per unit time. Number of instructions being completed per unit time. And in case of washer, in case of our laundry example, the throughput is the number of loads completed per unit time. Number of loads completed per unit time. Now you can very easily see here that every half hour one load is being completed. Okay, every half hour one load is being completed, or every 0.5 hours one load is being completed. So time time to wash a single load, time to wash one load in single cycle operation is 2 hours, 2 hours. And in pipelined approach, every half an hour one load is completed. So again you see that this is equal to 4. This is time to finish one load from washer to dryer to pressing to hanging, and time to finish one load. And this is time interval between successive loads in pipelined approach. Pipelined approach. APPROACH. So this is time to wash one load, and this is time interval between completion of successive loads, consecutive loads. Okay, and this is the gain that we get through pipelined approach. Okay, so now it turns out that MIPS also has a pipelined architecture, and in the MIPS architecture there are 5 stages of pipeline. There are 5 stages of the pipeline, and so you would assume that a pipeline MIPS processor would probably have 5 times the instruction throughput of a single cycle MIPS processor. It turns out that this is not the case in case of MIPS, and we will see why. The gain is not 5 in case of MIPS, but it's slightly less than 5, or maybe it's approximately 4. We will talk about that in the next part of this lecture. So at present we have completed our general introduction to pipelining, very basic general introduction to pipelining, and we have seen how pipelining improves the throughput by overlapping the operations. How pipelining improves the throughput by overlapping the instructions. So let me see if I can show you a figure. I hope I can show you that figure. Let me actually what is this thing? Okay, got it. Let me download all these items. Okay, let's go back to our let's see if we can insert a PDF here. Okay, there we go. So it's a beautiful example. Look, so this takes 2 hours, this takes 2 hours, 2 hours, 2 hours. Now this is single cycle approach. Single cycle approach. Okay. Now look what happens in the pipelined approach. Now at this point between 7:30 and 8 o'clock, all four stages of pipeline are busy, and this is what we call, let's use a good color, pipeline is full. Pipeline is full. So we want to keep the pipeline filled for as long as possible. That's what gives us performance improvement. Okay. So if I'm not wrong, this is figure 4.25 of your textbook, and it is on page 273. Okay. So we are going to, in the next part, we are going to see how this concept applies to MIPS processor, and what are the pipeline stages, what are their names, and what are the implications of this pipeline approach in MIPS. Okay, so this is where I'm going to stop, and in the next part we will be discussing the pipelining in MIPS processor or MIPS architecture. So I'm going to stop, and there we go.